So the way that I started out my project was thinking about what is engineering and what is biology. Biology is basically just anything to do with nature, where engineering is trying to make something lighter, better, tougher, or stronger in general. Just improving upon the basic design or making it cheaper, more efficient. So my initial concepts were along the lines of an exotube, something that probably any of us have thought of at some point in our lives. But that would be too expensive and complex for something on this time scale or what we're able to do. Nothing that I could really do about that. A bioluminescent motorcycle safety gear, so basing that off of something like a firefly or anglerfish and trying to increase the safety for, again, either motorcycles or bicyclists out there. And then I thought of a neural reconnection catalyst that would speed up the reconnection of any type of neurons for, like, say, a spinal cord injury, which that is found in freshwater turtles. They have a quality about them that allows them to reconnect their spinal cord if it gets broken in some way. But again, wouldn't be able to do that, and the bioluminescent materials would be a little bit too difficult to get. So then what I went on to after that was, okay, let's just break this down to the most basic thing. What could I do, and base it off of biology. I went with a titanium, a form of spiderwebbing based concept that would use, my initial thought was titanium. It might work better with, say, an aluminum or other types of metal, and attach pieces of that via elastic and coat it with a carbon fiber type material, and have that work as a better type of bungee cord or a cabling, and see if that would be lighter or more efficient than what we have nowadays. Basically, the entire theory behind that is that spider webbing and bungee cords use the same properties of turning kinetic energy into potential energy, using Young's modulus of each material. So I went with this because it would be relatively cheap and easy. And the one downside to that is that the design that I'm basing it off of the spider webbing, if I mess up one part of that, it would have to restart the entire construction of the cabling. So what I was thinking with this was, why is this seemingly so easy, but could, in theory, improve upon a design? Well, we're not always looking at what the best engineering that we have so far is. Nature. If you say engineering to a common person, they think of like an iPhone, computer, anything like that. But you can also look at, say, the Grand Canyon, any type of natural rock formation, or spider webbing in this case. So again, going into the science behind it, I'm trying to turn the kinetic energy of an object in fall, or just trying to keep it attached to a structure, and have that turn into the potential energy that it could have via the modulus of elasticity of the elastic, titanium, and slightly, but not so much the carbon. Carbon is more just a skin for the cabling. So it would be used for mainly any aspects that a bungee would be, so connecting, say, towing cars or something like that, keeping it shrunk down, bungee jumping, if it's as effective as I'm trying to make it to be. And right now, just questions.
All right. Questions?
All right, so I'm unclear on exactly, you're going to create a bungee cord out of titanium?
It's not the cord itself is made out of titanium. It would be, the design is based off of spider webbing. So spider webbing is strong because of two of the aspects: the proteins that go into it and the design of how the fibers interlock with one another. Spider webbing is able to stretch up to like 3 times its size and go back to its original shape because of, again, both the proteins and the structure of it. So what I'm trying to do is I'm trying to make a multi-layer bungee, going back to that, so to say, and have that connected from the layers via the elastic, and see if that would not improve upon a simply elastic cabling.
Okay, so you're going to create a composite structure that simulates the microscale structure of spiderweb.
In a way, yes.
Okay.
On a larger scale, but yes.
Oh, why titanium?
I was thinking of that because the cabling would not be thick. This wouldn't be for something, say, like 4 feet in diameter. It would be a fairly thin type of bungee, and it would be using the titanium, quote unquote, would be a form of spring or multi-layers of springs connected via elastic. So with a spring that small, titanium wouldn't be as resistant to the stretching. So I'm going back to, again, the modulus of elasticity of titanium, and that would seem fairly reasonable. Maybe aluminum would be a cheaper, better method, and maybe not. I'd have to test it out with each of the modulus of elasticity of each of those.
You also said that it's hard to make, like, you mess up one, you have to redo it. Wouldn't that, like, make the cost of it, like?
I'm saying like each of the layers would be built off of one another. So if you mess up on the first one and you get to the third one, and you find out that you messed up back there, you have to restart. So it would have to be constantly built off of one another.
But wouldn't that make it like an expensive product in the end to like sell it? Because it was so hard to make.
It's easily when I say easily messed up, I mean the entire thing is messed up if something goes wrong. However, the process of the connecting and the springs themselves, that's not complex. That's not easily messed up. But if something goes wrong, then it has to be restored.
All right, Jen, so my thing is more of a suggestion again. I think where you're going is, there are two like very critical aspects of your concept. One of which is the design, like you're really promoting the spider webbing, right? And that's so you can look at already existing engineering design of your bungee and then make your own spider webbing design. How that makes a difference, right? In the process. That's a prime thing that you can, if you can go into modeling of this. Again, you don't have to go and buy all of these, very expensive equipment. Start getting into the model if you can. That's probably the best approach, is now get into modeling your spider web as compared to the normal standard, whatever engineers are now using for bungee. That in itself is already a good accomplishment just for this semester, and we'll see from there. Now, if that proves to be workable and good, then you can move on and explore on, okay, are you going to be using titanium or whatever is the best, material that you can probably use with this design. But I would suggest concentrate on that, since it's a big scope. You can go into the engineering of this as far as you can go, but first settle on the real concept that you want to bring in, which is your spider webbing design as compared to the normal standards.
That's what I was
Does that
saying.
make sense? Yeah, I think that's the best. It would be more feasible to work with the advice of the experts that you have here. Just approach any of them. I'm sure they're going to give you wonderful advice.
That's what I was talking to him about. I'm not entirely certain on the exact properties of the material. Going again, it all depends on the modulus of elasticity for each of these things, because it has to be able to go back to its original shape
Yeah.
and not break.
Yeah, and also once you get that spider webbing, then it's easy now to test. Is titanium the best to do for this one, or is it going to be aluminum or whatever, or maybe an interface of this and that material? You never know. But so concentrate on the design. Okay, I think that's the best way to go.
And that's the only resource that I used, because the only thing that wasn't common knowledge in that was the thing about freshwater turtles.
All right. So any guys?